All right, take a look at this argument. All professional soccer players are athletes. Therefore, it is false that no professional soccer players are athletes. Okay, I'm going to always begin by evaluating arguments from the Boolean standpoint, because any argument valid from the Boolean standpoint will also be valid from the Aristotelian standpoint. To evaluate from the Boolean standpoint, we rely on the modern square of opposition. It's the modern square that's associated with the Boolean standpoint. And to use that square to evaluate the argument, I locate where on the square my premise statement appears, which is an A statement offered as true, and my conclusion statement appears, which is an E statement offered as false. And I can see that the line connecting corresponding A and E statements is a broken line on the modern square of opposition because the truth values are logically undetermined. So even given that we assume the A statement here is true, according to the modern square, we can't draw any conclusions about whether the corresponding E statement is true or false. And that tells us that from the Boolean standpoint, this argument is invalid. But what if we dropped that perspective and picked up Aristotle's perspective? We work from the Aristotelian standpoint, and now we're going to assume that professional soccer players is a thing that exists in reality. And so now when we read this premise, we're being told that this thing that exists in reality, professional soccer players, all of them are included in the category called athletes. All professional soccer players are athletes. If that's the case, if we assume that to be true, is there any way the corresponding E statement could be true? In other words, if it's true that all professional soccer players are athletes, could it also be true that no professional soccer players are athletes? And we'd say, no. If they're all included in the category of athlete, they can't at the same time all be excluded from it. Therefore, it seems like this E statement has to be false, and that's exactly what the conclusion asserts here. And that tells us something about the Aristotelian perspective. It includes what's called the rule of contrary, or the rule of contraries. The rule of contrary says this: if you have an argument that involves corresponding A and E statements, at least one of them has to be false. They can both be false, but at least one of them has to be false. They cannot both be true. Okay? And you can see I've modified the top line of my square here, almost as if I'm creating a new square of opposition, to change that broken line connecting corresponding A and E claims to be a filled line. And I've even got an arrow going back and forth, and my reminder up here of the rule of contraries. Okay, so corresponding A and E claims can't both be true at the same time. They can both be false at the same time, like it's false that all dogs are brown animals, and it's also false that no dogs are brown animals. But it can't be true that all dogs are canines and true that no dogs are canines. Okay, so the rule of contraries says, given corresponding A and E statements, at least one is false. So then you look at an argument like this: no funny people are boring people. That's an E statement we're being told is true. And therefore, it is false that all funny people are boring people. That's the corresponding A statement. And according to the modern square, we can't draw any conclusions about that conclusion statement and whether it's true or false. So that tells us from the Boolean standpoint, it is invalid. But the rule of contraries from the Aristotelian standpoint says at least one of these corresponding statements has to be false. They can't both be true. And so if we assume this premise statement is true, the conclusion has to be false. And that's exactly what it says. And that tells us that this argument is valid from the Aristotelian standpoint by the rule of contraries.